Well, good afternoon. Thank you so much for joining us. And today I have Dr. Jay Wiles, who will be joining me on the STEM Excellence podcast. My name is Amos Tarfa. I'm a medical physicist and math curriculum writer. And I've used Berean builders with students for years, and I love it. And I told Dr. Wiles at the conference in Texas that I would love to do a podcast. So he's here today. I'm going to have him introduce himself in a second. But this podcast is mostly watched by homeschoolers and people who are trying to provide high quality math and science education to their children. So Dr. Wiles, who is Dr. Wiles?
Well, I'm Jay Weil. I got a PhD in nuclear chemistry, and I actually did some nuclear medicine stuff. So I guess we have something in common.
Yes.
I did some clinical trials with shooting protons in people's brains to kill tumors.
Yes. Wow.
And also when I was in university, I actually did calculations to determine how long nurses could stay in the room with people who had just drank the radioactive iodine for their thyroid.
Yes. Yep.
So yeah, I've done a little bit of that, but my main focus is fundamental research. So I was actually looking at how protons and neutrons give up a little bit of themselves to become part of the nucleus and how that
Correct.
works out. And so that was what my PhD research was in, and that's what I concentrated on when I was a active professor and researcher. I spent 6 years teaching at university
Yep.
as an assistant professor, and while I was at Ball State University, which is a university in Muncie, Indiana, I started running into home educated students. Now, at the time, I didn't know anything about home educated students, but they turned out to be my very best students. And so I was interested in that mostly because, I'd never experienced. I remember the first time that a student asked or was talking to me about this, and he was my top chemistry student that year. And when I learned that his mother had essentially taught him, I said, "So she's a nuclear physicist then?" And he said, "No, she never went to college."
Wow.
Yeah, she provided me my best student that year. So I actually got interested in working with homeschoolers just because I wanted more of them to come to Ball State University.
Oh.
But pretty
Wow.
soon I started writing curriculum, and that was pretty well received in the homeschooling community. And I found that I really do feel like I was doing more effective science education writing homeschool curriculum than I did as a university professor. So I went full time doing homeschool curriculum for many, many years. But after my homeschool curriculum got more established and so forth, I did go back to teaching at the university level. So right now I'm doing a little bit of both, a little bit of curriculum writing and a little bit of teaching.
Wow. And how long have you written curriculum? And a lot of people know you from Apologia and some of the work you did there. How long have you been involved with curriculum?
So I've been writing curriculum since 1994.
Okay.
So I've seen in the US huge changes in the homeschooling community and what homeschooling parents are like now compared to where they were when we started and so forth.
Wow. That was when I was in first grade, by the way, not to make you feel old, but I was just figuring out what life was about. Okay, wow, that is amazing. I was actually, so quick side tangent, because this might tie into our conversation later on.
Sure.
When I was in first grade, I went to school in Lagos, Nigeria, which people might know. Lagos, Nigeria is the most populated city. I mean, one of the most populated cities in Africa. And I moved from the northern part of the country to the southern part of the country. And it was during these years that I was blessed to have a very good science teacher. And my passion for science and mathematics led me to the science club. And I ended up becoming the, at the end of the school year, I would have to give a presentation where I would tell people the scientific names of different plants and things. That was what I used to do for fun in fifth grade. So that's what I did. I ended up doing a lot of math and science, and I loved it right from that age. So anyways, when you talk about 1994, it brings back memories. The reason why I bring this up, sir, is that I really believe that your approach, which we're going to talk about here shortly about science history, I believe that more children, even in Africa, could benefit from some of this strategy that you use. Because if I was exposed to Berean builders as a first grader, like I might have won the Nobel Prize at this point, and so I really appreciate the work you're doing. But I'm just saying that as we're talking, I'm actually honestly in real time thinking a little bit about, wow, I wonder what can how Biriam Builders fits in with that Nigerian ecosystem as an
Mm.
enrichment to help more children learn the history of science. So that leads
Right.
me to one of the core topics today, and then we could go back to anything else, which is why did you write the Science in the Beginning series with the history of science embedded, and what have you noticed over time with the reception of it?
Well, actually, I kind of came about it in a roundabout way. I wrote Science in the Beginning specifically as a favor to a curriculum company in the U.S. called My Father's World,
Mm.
and they put together books and so forth, and they basically make a syllabus for you and everything. And they had a book called Science in the Days of Creation that was going out of print, and
Mm.
they wouldn't be able to get it anymore. And so they asked me, would you consider writing something like that?
Yes.
And so I had some time, and I hadn't really done elementary before. So I said, sure, I will give that a try. And so that's where Science in the Beginning is. It's the 6 creative days of Genesis and learning a little bit about what was made in each day and so forth. And
Yep.
when I got to the end, I thought, well, I have really enjoyed this because one thing we do in this curriculum is we have hands-on activities for every lesson. My wife's a physics major, got her master's degree in library science, but so she would help me with a lot of the experiments, and so it was fun working with my wife, coming up with these crazy experiments that she can do at home and so forth. And so when I got done, I thought, well, I should just continue because we've
Yep.
now reached the beginning of human history.
Yep.
After the 6th day, we got
Yeah.
the beginning of human history. Why don't I just start from there and see what
Right.
happens? And I wasn't really sure whether it would work or not. But and part of it is, as I learned as I was going through this, a lot of what I was told about science history when I went to university for science was wrong.
Wow.
So I had to, I found myself, I had to read portions of all of these great writers because the historians disagreed on what they said, which is crazy because it's all right there.
Yes.
But
Wow.
so anyway, I found I continued enjoying working with my wife on all these experiments, but also reading, all of this early work in science was really fascinating.
Wow.
And so that kept me interested. And I thought, if this is keeping me interested, I would think it would keep a lot of people interested if, I did it the right way.
Correct.
So that's, because
Wow.
honestly, you probably know this as well. As a scientist, you're focused on your stuff, and you
Yes.
find your stuff incredibly exciting. You don't
Correct.
find a lot of the rest of science exciting, but I
Yep.
found it really exciting reading it from that perspective.
Wow. That's really fascinating. And I want to encourage families to really, really step back and ask that question of think about if you tell your child, here is this concept without any context or any stories or anything, and you tell them who's behind it. Just think about that can play a huge role. And I think one of the ways, maybe this is an indirect implication of your work, sir, is that maybe somebody might get inspired to go into science because of the story they read about the person. And I
Well,
don't know if those.
I've certainly gotten emails from students saying that.
Wow.
That they became interested in science specifically because they were doing that elementary
Yep.
series, and so now
Wow.
they're either in high school or early university, and they're studying science because of that.
Wow. Well, if you don't mind, let's just take maybe one quick minute and kind of give people a framework of your curriculum. So this will be a key stage. So I know there's 5 books in the series. And then, so yeah, if you don't mind, if you take a first grader, how can they interact with Dr. J. Wiles from first grade to 12th grade?
Okay, so what's really neat, and this is something that the folks at My Father's World told me to do. I didn't think of this myself; it's something they did. Every lesson is designed for all ages of primary school to do together,
Wow.
and uh, and that's one reason there's a hands-on activity in every lesson because that even allows the very youngest kids to get something important out of it. But at the end of every lesson, there are 3 levels of review. And so you have a review for the youngest students, which is just a couple of oral questions and then they're done. A review for the older students, which is a simple notebooking activity. And then the oldest students have a more complex notebooking activity. And that way, if you have, one kid in first grade and one kid in 5th grade, they're doing the same lesson.
Yep.
They're just doing different levels of review to make sure they all get the same out of it. And so the whole elementary series is structured like that.
Okay.
And so the only thing that's different is, the first book is about the days of Genesis, and
Yep.
you'll get a little overview of everything that's in creation. And then we just start with the ancient Greeks, and science was done by folks other than the ancient Greeks, but we have the most records
Yes.
from the ancient Greeks, so they're the most reliable to at least turn to for ancient science. And so then we just go through history.
Okay.
And all the different books as you go from book to book. It's not like one book is made for one level of student. All the books are made for all levels of students. You
Wow.
just progress through them as you go.
Wow, that is really cool. So that takes care of your elementary, first grade to fifth
Mhm.
grade. And I actually remember the name: science in the beginning, science in the ancient world, science in the scientific revolution, science in the age of reason, and science in the industrial revolution.
Yeah.
Yep. So I love that demarcation. And honestly, before we look at middle school and high school, honestly, I would love, like, imagine there was a video conference, or, well, not video conference, like a live lecture where you cover all the content in the historical time frames. I mean, that would be like gold, then people can
would be.
watch you like a master class. And maybe you already have that, but I'm just saying that would be
Yeah.
cool.
I don't. I remember sitting through a class like that was on modern philosophy, and it was
Wow.
one long class on here's what modern philosophy, here's how it developed. So that was
Yes.
very interesting. Yeah.
Wow. Wow. No problem. Okay. So then what happens after elementary school when they get into middle
So
school?
yeah, at some point we have to start focusing on individual level though, because
Okay.
at some point the student's cognitive level has gotten to the point where I can challenge them with
Yep.
certain things that I couldn't challenge a younger child to. And so that's where middle school is. And for middle school, we're very flexible on what that means, especially since it's homeschool related. What I generally say is middle school is really 2 years before you take algebra 1. So
Yeah.
where, whatever age you are when you're, 2 years away from algebra 1, that's middle school for you.
Correct.
And so middle school, then we wrap it all up with a book called Science in the Atomic Age,
Okay.
which is the students' first, grade level type book. And it's teaching them, first of all, it's teaching them how to document experiments, because that's really
Okay.
important. But also then how to reason through different scientific controversies and things like that.
Yeah.
And then the next book is Discovering Design with Earth Science.
Okay.
And that does the science of the earth, but also space. And then we do the standard biology, chemistry, and physics in high school.
So if you don't mind, let me count. There's 7 years. I'm just curious for a traditional
Sure.
middle school family. So if there's 7 years, I think we've listed earth science, atomic age, biology, chemistry, physics. So notice there's
Right.
2 years that are kind of
Sure.
like up in the air. So how do we navigate a sixth grader who says, I want to go all in with Dr. Wiles for 7 years? Do we say
Right.
that, no, you just have to do 5 years with us?
Well, one thing is you want to be flexible with some students, because some students are going to take longer.
Yep.
And I think it's more important to cover a book than to finish a subject in a year. So,
Okay.
if it takes you 1.2 years to finish the biology, or 1.5 years to finish biology, do that.
Okay.
Don't just stop at the end of the year and then go on to chemistry. So
Yeah.
that allows you to have some flexibility, because some students it would take 7 years to cover those 5 years worth of
Okay.
topics. For the students who have more time and are interested, because if you cover biology, chemistry, and physics all at the high school level,
Yep.
you're in the top 19% of all graduating high school students in Indiana.
Wow.
Or in the US, because
Wow.
only 19% of them have had all three. Most of them skip physics.
Yeah.
But most of them have biology and then either chemistry or biology and physics, and that's it.
Yep.
So you're already pretty advanced. But
Yeah.
for students who want to be even more advanced in science, Apologia still covers or carries several advanced courses that I like.
Okay.
So they have My Advanced Chemistry and My Advanced Physics, which is a second year of each.
Okay.
And if you take my first year of Berean Builders and then the second year with Apologia, that's the full year of university level.
Wow.
So that gives you a really good, and we call that AP, and there's a test
Yep.
you can take, the AP test, and so forth. So that's available. Also, what I recommend, actually, if you can, and if you can afford it and find it and everything, is actually either have your child go to a local college, or get a serious university online course.
Yes.
Where you register and have to take the tests and all of that, and start getting your feet wet in terms of taking it at the university level.
Okay.
Because if you take my chemistry, you're ready for any first year university chemistry course.
Yes, sir.
So I think there are lots of options, but we make
Okay.
it flexible so that students have lots of different ways of completing it.
Okay, no problem. That makes a lot of sense in terms of thinking of those 7 years with those 5 books and having some flexibility. That's wonderful.
Yeah.
I think that anatomy and physiology is sometimes offered as as an option for people. So I grew up in Nigeria, and it's a little different in Nigeria, where in 7th grade, 8th grade, and 9th grade, we do something called integrated science. What it's basically your science in the atomic age. That's kind of Nigerian 7th, 8th, and 9th. Here's where things get a little crazy, and I would love to hear your thoughts on what they do. In 10th, 11th, and 12th grade, you actually do chemistry, physics, and biology all at the same time every year, all 3 years. So the idea is that you're getting exposed to all the sciences for those who are in the science track like I was. Have you ever heard of this system where you're doing multiple sciences at a time?
Yeah, so Canada does something similar. They don't make you take all of them every year, but they have biology 10, biology 20, biology 30, and the same for chemistry and physics. And so you could be taking biology 10 and chemistry 10 and physics 10 all the same year.
Correct.
And so that happens in other countries. My problem with that is that, first of all, the sciences are sort of separate in the way they use math.
Yep.
So you can't really teach a lot of chemistry without algebra.
Yes.
And so you're kind of teaching just sort of a small section of chemistry prior to when the student has algebra. And it's even worse for physics because you really need the trig functions to do vectors, and you can't really do much serious physics without vectors. So I feel like what you're doing when you're trying to do all of them, all 3, and I understand the idea. The idea is if you keep doing it every year, you're more likely to remember it later on. And I think that's the general idea there. But honestly, I think you are artificially reducing what you can teach in every year until the math catches up. So why not teach them as much science as you can that matches their math level?
Yeah.
And that usually is biology first, then chemistry, then physics.
Then physics. Yeah. So the funny thing is, you made me smile when you said their math level, because I'm a math guy. So I'm like, give them more math. But let me actually extend what they do beyond just their science. So then in 10th, 11th, and 12th grade, here's what they did to us. I say they did to us because I didn't think it was funny at the time. We had to do a regular math course, an advanced math course pure, and an advanced math course applied, they called it. This meant that I had literally about 10 teachers just for my math and science a year. Yes. So I had 3 math teachers, 3 chemistry teachers. Oh, I didn't tell you this part about chemistry. They split the chemistry based on organic chemistry, physical chemistry. And so it was intense. Now, what does that do though? You would notice that a lot of students who come from Nigeria to the American system in chemistry come very strong because they've done a lot of chemistry, right? I did chemistry for my bachelor's degree. And so now, I don't think it's a perfect system, but it's definitely worth kind of exploring to see if there's any lessons we can take out of it. But you've made me think more, and I'm going to dissect it. So next time I'll write you a paper.
Well, and one thing is, I am doing this in the context of the US and Canada. And in the US and Canada, our math system is very different from what you're describing. And so I would think that if the US and Canada were committed to a different kind of math system, then that kind of science system could work really well. And I do think we don't demand enough from our students. And so in the US, and it sounds like Nigeria actually demands more from their students. And this is probably why the Nigerian students who come to the US are advanced, because more has been demanded of them. I didn't experience a lot of Nigerian students, but I noticed that Asian students that I had at university were significantly advanced compared to most of their American counterparts. And it's the same thing. You could even argue they go to even a more extreme because high school suicides are pretty high in Japan, especially. And part of that is because of the intense pressure of the educational system. But you can see that when the educational system holds them to high standards, most students rise to them.
They rise to it. Now, here's the crazy thing, though. Nigeria doesn't have those rates at all, actually. And Nigeria has beat some of them in math in tournaments. So what I'm saying is that, but Nigeria also has a strong faith heritage. Let me just add that. So that's another factor, if you know what I mean, is that if you don't have that, piece, then your whole life becomes about academics. In
Right.
Nigeria, we know there's more to life than academics, and we'll come back to some of that later. But no, thank you so much for sharing that. And I think that when you grow up with only one system, you never question the system and try to see if it could be different. And that's all I grew up with. I grew up with high standards all the time. I never was allowed to slack off. And we didn't have 3 months off in the summer. We only got a few weeks off in after our third semesters between grades. So I think there's a happy medium, but I think we definitely need to demand more of our students. The question then becomes, what is the limit of demand? If you see what I mean, at what point do we tip? Do you know what I mean? Have you found an interesting balance or have you seen that pushing too much in America could lead to a detriment? And what is some advice for a parent who has a child who wants to be a physicist? How much should they be navigating things?
Yeah, so I have seen the consequences of demanding too much of your students, and this happens in homeschooling from time to time. You have these parents who, are pushing their students so hard, and generally, what happens is the student becomes totally. I mean, they'll do it, and usually these students, end up winning all these contests and everything. But once they're outside their parents' control anymore, they have no interest in academics at all. And so, you've pushed them to be this academic superstar in school, and most of the time they do it because they can, and you're kind of forcing them. But in the end, you kind of turn them off so that they don't go on and develop their talents in that area. They do something else entirely. So I do think you do have to find this happy medium. What I tell parents of all ages and all types of students is, the sweet spot for education is where you're challenging the student, but not overwhelming the student. And so if a student is getting hundreds on all of his tests, then you're not challenging them.
Wow.
If the student is getting 60s on most of their tests, then you're probably challenging them too much. And, and that's just one way. But as a parent, especially with a parent's heart, you should be able to tell when your child has moved from being challenged to being overwhelmed. And so that's that. And you can usually tell when your child's slacking off too. I mean, when I homeschooled my daughter, especially as a teen, I only had her as a teen, but as a teen, you could really tell when she didn't put the work in. So I think you can, as a parent, make that judgment. But for physics specifically, I tell parents that the most important thing, and this is true for science in general, but especially for physics, the most important thing is the math.
Yes, sir.
And I tell this all the way down to elementary. I say, for parents, if you get to one of those days where you have to choose which subject am I going to jettison today, then definitely choose science instead of math.
Wow.
Because math, it teaches you a very disciplined manner of thinking that pays off in all sorts of areas, including science. But then especially if you go into physics, it's just nearly impossible to do anything serious in physics anymore without some pretty high level math.
Yes, sir.
I work with a college called Memorial College, and they're mostly classic books and so forth. And so we read some of the classic scientists, and the math that they're doing in their books is just incredible. And it's so much that my students can't handle the math that's in these classic books. So I have to show animations and things like that show how the math works, because they just they can't go through that much math. So I think as a physicist, especially math.
So everybody heard that. Dr. Wiles says math. So then I have one philosophy question that's going to come up here in a second, but one quick side commercial break. Why do we see the Greeks' names showing up more when they start doing science, like Tales of Miletus and Eratosthenes, but we don't see anybody's name before them? Like, what's up with that? And what's different about the Greeks?
Well, okay, I think there are two things. The Greeks themselves had there's reason we still use Aristotle to teach logic, is because they had this commitment to disciplined thinking.
Yep.
And they had a religious beliefs and so forth, but they
Yep.
had an idea that if I can't logically prove something, then in the end I shouldn't really pay much attention to it.
Wow.
And that's kind of unique to that area of the world. You didn't see that in a lot of other areas. Now you saw that for a while in the Arabic regions, especially in the early years when they were doing so much math.
Yep.
You found, but that kind of went away when Islam got really fully established. That commitment to logical thinking kind of went away, and so the Greeks kind of filled that void.
Yeah.
But also, I think the Greeks were committed to the mathematical end of things. So, Archimedes, he didn't do any experiments. All he did was mathematically derive things. So his law of buoyancy was a mathematical derivation. His lever arm rule is a mathematical derivation. He actually, you don't know anything for sure, but most of the reports are he didn't really even care to build anything.
Wow.
All the war machines and everything were made by his, under him. He didn't do any of the work. He just said, here's the math, go do it. So I think that's the Greeks had the best, sort of fundamental underpinning. Now, what the Christians did, why science took off in the Christian world then was, in addition to this very logical, and all the Christian thinkers were taking Aristotle in terms of logic and everything. They were all using that. But the difference is they then were looking for established laws. They were looking for natural laws, because in the Christian world, God gives his creation laws. He gives his people laws. He gives his nature laws. So they had something the Greeks didn't have. They had this underlying view that there should be laws that nature follows.
Wow. That's really deep. And I think that everyone graduating should learn, like parents who are teaching their kids science, you want to ensure that they understand those two pieces. That's critical, because a lot of Christians go to college sometimes that they don't have that apologetic for understanding why the scientific revolution happened and the way it happened. Why there, why then? As Dr. Stephen Meyer says, why there, why then? And others say it too. And there's something about that. I tell people that you had Copernicus, you had the printing press, which came before, Copernicus, and then you had, the Reformation, with some more people are reading and thinking, and then you have the, I think Bible translation in Europe actually was even interesting. There's a lot of Bible translation happening right around this time, and a lot more people are seeing and learning about the world God had made. And so I think that's interesting for the scientific revolution, which is another interesting era of time. And so one last question for you. What is your, well, actually not for you fully, but in your book series, what's your favorite time frame in the history of science?
Honestly, to me, it's the very early time frame, around 1000 AD to 1500 AD, because 1000 AD is when Robert Grosseteste comes along and says, look, you can't just think. You've got to do more than thinking, because your mind is clouded by sin.
Wow.
So what you have to do is you have to do something to turn your eyes to God. Now, how do you do that? Well, he thought in his theology, light was the most direct material thing that's closest to God, because it was the first thing created.
Yes.
So he said, you have to use light. Well, the way you use light is you observe things. When you observe things, that gets you out of your sinful mind and looking more towards God. And so he said, what we have to do is we have to develop a system of philosophy where we merge thinking with observation. And so then the next guy that comes along, who was obviously affected by his teaching strongly, Roger Bacon, actually developed the scientific method based on that. So if it hadn't been for Grosseteste saying we've got to do something to overcome our sinful nature when it comes to learning about nature, then in the end, Roger Bacon would have never developed a scientific method. So the scientific method is, in fact, uniquely Christian. And I find that whole time just fascinating, because you see especially if you read Roger Bacon's book, he just talks about all sorts of crazy things. And he just says, well, I'm willing to believe this is possible, but we better have some experiments to back it up. And it's just really interesting.
So it's funny because I'm more in the 1500s
Yeah,
and beyond, because I'm a Euler. Leonard Euler is like my
sure.
best, my children joke that my friends are dead. And that's one of my best friends, Euler. And so Euler, Maxwell, and Faraday are like my best friends in the history of science. And they all are more like the 1800s. Newton, of course, helped a lot. So I would say I'm more like a 1600 to 1900 kind of guy, if that makes sense.
Well, I have a colleague who's a mathematician who says that Euler's theorem, e to the I pi plus 1 equals 0, actually proves God exists
Wow.
because you have these three different areas of math that all come together to make simple arithmetic.
Yes,
He
sir.
says, how in the world can you do that if there isn't a design behind it all?
Correct. Yeah, I think mathematics is so the beauty there and the pointing back to God, I think is critical. So one other question for you. Do you notice a change in the tone of scientists from the 1870s after Maxwell to the years up till our time? What I mean is, are you noticing a change? Is there any
Yeah.
difference in the modern scientists compared to the ones before, or especially during the scientific revolution?
Yeah, there is. And it actually started before 1870. There was this undercurrent that goes all the way back to Erasmus Darwin, but there was this undercurrent in science trying to say we need to decouple God from science.
Wow.
And that's something that was an undercurrent for a long time. But some of the more prominent voices in science started picking that up right towards the end of the 1800s.
Wow.
And so, end of the 1800s, early 1900s, then it became pretty unfashionable to even mention God in scientific discourse. And that wasn't the case. I mean, you had James Clerk Maxwell would start every experiment with a prayer.
Wow.
And so,
Wow.
so in the end, there was this change, and it was mostly to try and get religion
Yep.
out of science.
Wow.
And so that changed the tone of the scientific literature. When you read the early scientists, they are talking about God all the time. They
Yep.
include poetry in their works. I mean, Kepler has just stops and recites a bit of a poem when he's talking about his three laws of
In
planetary
planetary
motion.
motion.
And you couldn't get away with that today,
Yep.
even though there's no reason not to.
Correct.
If I've got a poem that relates to my scientific work, why can't I include that in the paper? But you can't.
Correct.
So yeah, I think I see that
Yep.
change significantly.
And what happened for me is part of my PhD year that I did was studying the history of chemistry. And what I realized is Ludwig Boltzmann, that man came up a lot. And
Yeah.
one of the things is that Boltzmann built on the work of Maxwell, right? There's some of the work of Maxwell. So Maxwell, Boltzmann distributions and so on, which, by the way, as a quick tangent for our guests, do you know that Boltzmann is discussed in artificial intelligence mathematics? I don't know if people know that, but Boltzmann's name is there because of some of his equations. It's actually crazy. I didn't know that until I started studying AI mathematics. But what I find interesting is that if you look at the names of scientists after 1879, Boltzmann, Helmholtz, Max Planck, Albert Einstein, you begin to notice a trend. Well, first of all, a lot of them are from Germany because Germany won the Franco-Prussian War in 1871 and they became a dominant force, right? So I noticed how the history of the world even affects some of the scientific discovery.
Oh yeah.
But then I realized as I was compiling the names, I said to myself, the world needs another Maxwell. That was kind of what it came down to. I'm like, I miss the Maxwells. And one of the things about Maxwell is he memorized Psalm 119. I don't know if you know that part too. I found that interesting that he memorized Psalm 119. That shows how serious he was. And I went to Cambridge, and maybe someday it'll be fun for us to do a tour of Cambridge together, of Cavendish Laboratory, where he literally starts the Cavendish Laboratory that gave us J.J. Thomson and honors Rutherford. So anyways, I'm just sharing that I realized that drop off and it got me thinking. So that's why I wanted to ask you that question. One last question on this name. Who's your favorite of all scientists, other than the gentleman you mentioned, in the modern era? Or who's the best?
Well, I think the best scientist is Newton.
Oh,
I think he's the one that revolutionized at least physics the most by and anybody who was doing work 400 years ago and we still basically use him as a guide. That's some pretty good serious staying power there. But I think in terms of personalities and so forth and what they said, to me it was Robert Boyle.
wow.
Yeah, Robert Boyle was he he had these notebooks that he would do all of his work in, but he would also write other thoughts that he had, like
Oh,
right along while he was doing his mass measurements, he'd write, and he has all sorts of very wise things. My favorite thing he ever said was, "He whose faith has never doubted may justly doubt his faith." So if you don't question your faith, then you probably don't have it to begin with. And to
wow.
me, and that's just in one of his chemistry journals, one of his little notes to himself.
Wow.
And if you read, like when he retired, I think it was his will actually, he left almost all of his money to start this series of apologetics talks, so
Wow.
that there would always be once a year the Boyle lectures on religion and science.
Wow.
And they stopped for a brief time, but they've been going on almost continuously since his will. And
Yeah.
so I think he's done a lot to really show the difference, or the connection between science and Christianity.
And you know that he was friends with Newton. I'm sure you know
Yeah.
that. But
Oh
just
yeah.
telling
Sure.
our guests, and Robert Boyle is the same guy we talk about with Boyle's law. So
Mm-hmm.
those who remember Boyle's law and Charles' law, well, Charles is different, but that's another story. But I think that the Boyle was at Oxford, I believe, and
Mm-hmm.
Newton was at Cambridge.
Cambridge.
I don't. There's another Bacon I think our guests should also know, and that's Francis Bacon. He
Francis.
was
Yeah.
at Cambridge while Roger was at Oxford. So it's
Right.
interesting the Oxford Cambridge sort of interesting tension there. Okay, so let me move on to one more thing, and then we can begin to land the plane. So in terms of the 1879, so we've talked about those people. Your curriculum for science in the atomic age, I noticed that it's a little different in terms of like the flow, maybe not
Yeah.
taking the names of the scientists and listing them out in 90 lessons. Do you see what I mean?
Oh yeah.
So what is that flow difference? Do you feel like at that point they should be learning all the concepts in an integrative manner and then listing the people relevant to that concept instead of doing like the scientists of the atomic age by name, if that makes sense?
Yeah, so that I tried to make that book a transitional book. So if you look at it in real detail, at first it's a very historical discussion of how we came up with our model of the atom. And
Yep.
you do learn a lot of the names associated with that. And then it's a historical discussion of how we came up with how molecules form. And you learn a lot of the names there. But now, once I get to the level of tissues, it's extremely hard to do this historically, because
Yeah.
it happened in a short span of time and there were so many different people all working together.
Yes, sir.
That in the end, it becomes harder to do it historically. And that's in fact why once I get to earth science and biology, chemistry, and physics, we don't do a lot of history anymore, because it's extremely hard. You can't
Wow.
just say this guy came up with that.
Yep.
It's very rare. And even when a scientist has his or her name attached to it, it's usually just that person was the principal person,
Yep.
So it becomes almost impossible to do it historically when you get to the more recent stuff.
Yes, sir. So then one question about physics. What is the status of physics today in terms of, imagine, a Christian going into physics at a college level? I feel like it's almost been taken over into more of a naturalistic, circular humanism approach. What advice do you have for someone going into those fields in college?
Well, actually, I do think of the major areas in science, physics is probably the least against Christianity at the university level now than chemistry or biology, for sure. Because in the end, you still have an enormous number of people who are seeing all of the interconnections, and so it's rare to not find a Christian in a university's physics department.
Okay.
They're not going to be the majority there,
Yes,
but
sir.
yeah, but I think it's rare not to find one. But nevertheless, you still have universities are dominated by naturalistic philosophy. And this is something I made my daughter do when she went to a secular university. Was I think the most important thing a university student can do is to find an on-campus Christian fellowship group and be an active part of that on-campus Christian fellowship group, and hopefully draw most of your friends from that on-campus Christian fellowship group, because it's important to have older students who have already experienced that anti-Christian professor that everybody takes,
Yes, sir.
and so they'll see how the older students, quote unquote, survived, but also how they dealt with that. And I think that's by far the most important thing. If you try and go to a university, especially a secular university, as a lone wolf Christian, and just go to church on Sunday, and going to church on Sunday is really important. Going to church Wednesday night's important, but the church people there aren't dealing with what you're dealing with.
Yeah.
You need to find like-minded brothers and sisters in Christ who are dealing with what you're dealing with.
Yes, sir. Wow. No, thank you so much. That makes a lot of sense. I just want to make sure I haven't missed one of my questions here.
Okay.
But no, that is really encouraging. Now, if I can touch on math for a second on the mathematics side, and then I'll land the plane, because I'm more in the math space.
Sure.
And my vision is, the counting to calculus vision, which is helping everybody see the picture of mathematics from the most basic to the most advanced, all the way to differential equations. I want to give people, here's all the topics. You can go at your pace of mastery and so on and so forth, so that it opens more doors to science for you if you want to do that. I guess, what advice would you have to someone in my space in that kind of world, as trying to prepare them better for mathematics so that they can flourish much more in science?
Yeah. So I would love to have, high school students learning differential equations, because so often when students say, well, how can this be?
Yes,
I'd say, well, after you learn how to solve differential equations, come back to me. I'll show you how it can be, right? So how can a particle go right through a wall? I can tell you if you can solve some differential equations, right? So I would love that. But I do think that in the end, some students struggle with just basic, algebra 2. And I think, once again, we don't hold our students to a high enough standard, but there are some students who just don't respond well to math. So I do think you want a flexible program that, like you said, allows them to go however. And this is what I tell parents. I don't say, but that by the end of high school, you need to be at a certain math level. What I say is every year you should be working hard on math.
Okay.
And I think what you want to design is a program that, rather than being time based and saying, okay, finish this your first grade year and finish this your second grade year, have a program that is mastery based and say, and what will happen, especially, and I think you have to do this early. There's a company called Art of Problem Solving, and they've done this. If you start them really early learning higher level math, because a lot of kids in the early years, they get done with their math book in 3 or 4 months. So give them a program where they can get through all that arithmetic at their pace. And for some students, that'll be by 3rd grade, they're ready for pre-algebra. If you really give them, I think that's what you have to do. You have to focus on getting them in the early years. So, because there's no way you're going to get a student who's been in a traditional math program and then in junior high, get them to the point where they can do differential equations.
Right.
Because they're just not going to have the foundation to do that.
Okay, no problem. And I think part of the reason I want to do that is because, as I said, I'm trying to set the stage to get more people like Maxwell, if that makes sense. And so that's where I'm thinking of 3-year-olds. How can we prepare 3-year-olds, right? And I'm not trying to box them. They could change careers later, but I feel like there's some fields of study that are beneficial no matter what you do later in life.
So for math, I think it's beneficial to all subjects, even in subjects where you don't use it, because of the way it teaches your brain to think. So I agree. The earlier you can start kids counting and adding and subtracting, that's already a type of thinking that applies to nearly everything. So the earlier you can train them to do that, the better.
Wow. Thank you so much. One quick commercial break question. Do you think the 1 hour a day for a subject approach seems to work well? Or do you think they should do maybe some people try to do a lesson, which in your books, it'll be easy to do the elementary ones as one lesson. But what I'm saying is some people try a 1 hour block for science, 1 hour block. Have you seen that as an approach that is effective?
I think, we as people naturally try and schedule ourselves. And so especially when you've got, I've got a year to get through this book, that's what you're thinking at the beginning, then you're going to say, well, how much work is it going to take for me to do that? I think, everybody has to limit. There's no way I could, I love science. I couldn't do science 8 hours a day. Right. I gotta take breaks and things like that. So I think what you have to do is you have to find your students' own limit to how much they can take. And like for my daughter, when it came to certain subjects, that was a very short amount of window. maybe 15, 20 minutes. And that was all that she could handle for that day.
Yeah.
But then there are other stuff she could spend 2 or 3 hours on a day.
Yep.
And especially as they get older, I think you can find out what subjects they should spend more time with and what subjects they should spend less. But if you just say it's an hour a day, for some subjects, that's going to be too much. And for some subjects, it's not going to be enough.
No, okay, well, that makes sense. And then the last question then is, where do you see sort of AI playing a role in education and everything happening with education right now, as just this interesting spot we are in, both on a policy level, because I think there will be more potential opportunities with the voucher programs in some states for homeschooling, and then also for AI's influence. Where do you kind of see some of that going?
Well, I think fundamentally, AI is going to make many students more lazy.
Yeah.
Because are you going to read 3 books on how what happened in the scientific revolution, or are you going to ask ChatGPT, give me the 5 most important things that happened during the scientific revolution, and probably have some voice to text or text to voice where you're even listening instead of just reading. So I think. And there's a downside to that, because we don't learn by just getting a bunch of facts in our head. Yep. We learn by seeing how people thought about these things throughout a time and so forth. So I think that's going to make a lot of people's knowledge of science more superficial. And that's unfortunate, but I don't see any way around that, because people are going to be people, and most of them are going to take the easy way out. Yes, however, I do think you can show students how to use AI properly. And I try to do this even now with my students, because like I had one student, we were in chemistry last year, we were doing calorimetry experiments, and he was asking ChatGPT to solve them as I solved them, and he found where ChatGPT, what kind of calorimetry problems ChatGPT could solve and what kind it couldn't solve. And I found that really interesting. But I think what you can do is you can use AI, especially if you've remember reading something. This is how I use AI. I remember reading something about Roger Bacon saying something about beaver casters.
Yep.
And I remember that, but I don't remember exactly what he said. So I type into Perplexity, what did Roger Bacon say about beaver casters? And it will tell me. And so that allows me to not search the book, but it's referencing. I would at least not suggest asking any AI program about anything you don't already have a basic knowledge of. Because in the end, part of it is unreliable in a lot of cases. But the other is you're cheating yourself on learning. You're getting the end result, the fact you need, without having all the learning. But I think it's going to be increasingly difficult in education to get students to use AI responsibly.
Wow.
Yeah. Wow. But the one thing I will say about AI, in my opinion, and this is just my opinion, AI is the best test for the fact that there has to be a creator. Because AI assumes intelligence is all physical. That that somehow our brain is thinking because of electronic messages going through our brain. So if I can get the bits to do the same thing, then in the end that shows that intelligence is just material. I don't think AI will ever produce anything close to human intelligence, because human intelligence is not just material. There's a spiritual component to it. And that's something a computer will never have. So, and I'm willing to go, of course, I'll probably be dead before anybody has a chance of doing this, but I'm willing to go out on a limb and say nobody's ever going to produce an AI that shows creative human intelligence.
Wow. So I think that that is a whole nother episode there with AI, because I was talking to someone in Angola yesterday, and we talked about some of that. And I think that with the AI side of things, it's one of the first technologies that forces a worldview discussion.
Exactly.
And this is where Christians really need to focus on that. And reason why, part of why I say that is because a lot of the leaders in that field are talking about AGI, artificial general intelligence, and they're talking about some of them have these views of humanity that are just not right. And we have to talk about what worldviews they come from. Now, there are people who do AI research who are theists and who are Christians, but I'm just saying, I think that's a deep question that has to be answered. What impact will worldview discussions have because of AI?
Right.
And can we maybe start having more of those conversations? I think that's going to be critical. Yeah. So, wow. Thank you so much. I didn't know if you had any questions, thoughts, comments, objections. Maybe you can also share with our group what courses you are offering this fall and what is available to homeschoolers to sort of tap into.
Oh, so yeah, I teach only, I'm at the nice position where I can teach just what I want to.
Yes.
So I teach only for the high school levels, I teach only chemistry and physics. That's what I
Okay.
love at that level. So that's what I teach. And right now, this year, my classes are completely full. We we open registration in March, no, sorry, in late February. And then my classes are always full by the end of June.
Yes.
So, you know, if you want to take a class with me, you have to sign up early in the spring for the next academic year. But I teach
Okay.
chemistry and physics at the high school level. Now, I also teach at Memorial College, which does master's level degree. So you have to already have your undergraduate degree. And I teach the course I teach regularly is called Science and Natural Philosophy. And we show how we start with natural philosophy with Archimedes, and then we go all the way to modern science with Darwin.
Okay. Wow. And then what about other classes taught by your team with Berean Builders? I know in the past you've
Oh
had
yeah.
other people sign up for other classes.
Yeah, so we also have a very talented teacher, Lori McKeeman. She teaches the Atomic Age book, Earth Science book, the biology book, and she also teaches Apologia's Anatomy and Physiology book.
Okay.
And those, she usually has space in some of her courses.
Okay.
I know a couple of her courses are full, but some of them are still. So if you're interested in seeing what she has to offer, if you go to bereanbuilders.com and click on online classes, you'll see that mine are full, but you'll see that she has a lot that are available.
Okay. No problem. But nothing for the first 5 books in the Science in the Beginning series for those homeschoolers.
Yeah, you know, I'm not sure how that would work online since it's so activity oriented.
Okay.
You know, that it really needs to be supervised by a parent there. Now, we do have audio books for those. There's this wonderful South African company called Oikos that that Berean Builders gave permission to do audio books. And so you can, and each lesson is 3 tracks. It's the stuff before the experiment, then the experiment instructions, then the final stuff. And so most people skip the experiment instructions because they have to kind of look at that. But you can at least have somebody reading you the reading before and after the experiment.
Okay. That makes a lot of sense. Okay, no problem. So they can go to your website, they can get that information. I just want to make sure I have all of the pieces in my head correct. Okay, that makes sense. No, that is excellent. No, thank you so much. I mean, it's been a blessing. You've given me some homework to think about. I'm on a quest by God's grace to solve the American math problem, I call it. I really want to solve it and help more people love math. But I just love the history of science and how you do what you do. So thank you so much, sir.
Oh, my pleasure. Happy to do it again sometime.
Yeah, so maybe parents, if you guys can email me questions, I'll package them and then maybe send Dr. Wiles one email about all the questions. And then we can just kind of see, at some point, if you don't mind, I think you have some very deep insights, even just a little you shared on AI. So I would love to sort of kind of just nerd out about, think about AI and just the worldview side and how we can maybe get more people wrestling with the questions that they're not. I just feel like people are not realizing the worldview element that is so critical, to think that we can just reduce intelligence to chips, and that really troubles me. So anyways, thank you so much, Dr. Wiles, and that's where I'm going to stop the episode. If it's okay, I'll hang out with one of you after the call. So thank you again.